Okay. So I'm going to call it very, very just basics. You understand matrix basics tomorrow. So what we're talking about today is not on the quiz tomorrow. It is not on the quiz tomorrow. Again, quiz tomorrow is just basics of addition, subtraction, multiplying by scalar, and then a couple multiplying ones. It's very, very basic. If you don't have a graphing calculator, you want to come get one today, because we're definitely doing some matrix stuff in our calculator today. And then I want to do math workshops, but they're last week's, not the ones she handed you yesterday, the ones from I passed about last Friday, I believe. Okay. I'm needing lots of help, and I'm willing to give out lots of points. I finally also have a bunch of, if you've turned in anything that I took home with me this weekend, I finally have it graded and can hand it back to you as well. Okay. I need help with number 1 on the factoring. I heard GCF. What am I supposed to pull out? Okay, Daniel and Nick get a point. You'd be left with 11x squared, y to the third, minus 7, y to the fourth, plus 9x to the third. Is that correct? I believe so. Yes, dear. You have it again. I passed it out last Friday. It says 1016 at the top. We've got to handle that one first. Then it'd be in the Friday. It's 1016, and it would be in the Friday, so look in the Friday section. I don't know what Friday's date was. 1020? So look in the bin and algebra tutoring in the 20. Would be my suggestion. Okay, number 2, I butchered last period. Can someone tell me what we're supposed to do on number 2? We are, and we actually need to save number 2 till the end. So we're going to skip it for the moment and go to number 3. Number 3, I need 2 things that add to give me 5 and multiply to give me negative 6. Negative what and what?
Negative 1 and 6.
C minus 1. Okay, so 6 minus 1 is positive 5. Negative 1 times 6 is negative 6. And you are correct, and you may get a point. I like the haircut. Okay, and then number 4 is definitely one of my favorites because it has
Square roots. No,
square roots. It has perfect squares, so I get a point. So 16 is 4 squared. What's 225? And you can have a point. So it's 4m plus 15 and 4m minus 15. Anytime I see perfect squares, I know something cool is about to happen. Since we're already handling perfect squares, let's handle the other. Did you find it? Okay. Let's handle the other problem involving perfect squares. What other problem involves perfect squares? I heard it from 3 and 5. 4. 3 and 4. Okay, 441 is what squared? I know 169 is 13.
21.
Thank you. So it's 21 minus 13h. Jack, you can have a point. And 21 plus 13h. 256. Okay, and then Daniel probably wants number 7 via what he said a few minutes ago if he thinks it through. Yes, so it's e minus 2 and e minus 3. Negative 2, negative 3 is negative 5. Negative 2 times negative 3 is positive 6, so you can have a point. That's what he tried to answer on number 3. Literally, the difference between 3 and 7 is just with signs. They both have a 1, a 5, and a 6. It's just, on number 7, it's a negative 5 and a positive 6. Whereas on number 3, it's a positive 5 and a negative 6. It's literally just signs. But the signs change the factors. Okay, and then let's go to number 6. There are 4 terms, so I'm assuming grouping. What can I pull out of that first group? Woo, m squared?
N squared.
But that one has an m. Oh, it's an n?
Yes.
Okay, you win. You win, Ellie. You can have a point. Trying to make life difficult. So n plus 2. And the other one, I'm going to pull out a negative 9, and I'll again be left with an n plus 2, and I'm happy. Why am I happy? Because they match. So I'm going to have n squared minus 9 times n plus 2, and I'm actually not done.
N squared minus 9.
2 and 5 get a point. N squared minus 9 is a perfect square. 9 is a perfect square. So I can break that down into n plus 3, n minus 9. I mean, n plus 3, n minus 3. Good grief, Miss Compton. N plus 2. Because if you were to FOIL this first 2 out, you would get n squared, negative 3n, positive 3n, negative 9. And seriously, I just knew I could go further when I saw a perfect square number. Anytime I see a perfect square number, I think, hey, is there anything else I could do? Okay, now let's back up. Let's do number 5. I'm mad at 2 and 5 today. I'm having kind of a blonde day, so we're going to have to work on those. So 5, there is something I could do. And what is the GCF? Thank you, Jack. So you can have a point. So I factor out, and I'll be left with x to the 4th plus 7x to the 3rd, y to the 3rd, minus 8y to the 4th plus 14y, which is great. Except from here, if you try grouping, you're going to fail. So first period, I said the words, we'll just stop here. Like all we could do is factor out the x. But I really don't think that's true. I think we can factor by grouping. I just think we need to rearrange our groups. So in the past, we've just, the first 2 are one group, the second 2 are another group, and we roll with it. I'm wondering if we rearrange the terms, if life would work out better with factoring. So regardless, I'm still going to leave the x on the outside, and I'll still do x to the 4th. But I really think I want to put that 14y next. Then the, see, I'm not really happy with that either. Let's try grouping, but I think I'm going to be mad at it the way it was. I really think we could strategically rearrange the terms and make life work out. But I'm having a Monday, so we'll see. Okay, if I left it as it was, I could pull out what? Okay, if I pull out an x to the 3rd, I'm left with an x plus 7y to the 3rd. But with that second term, with the 8 and the y, like, I'm going to be left with the y to the 3rd, but it's not going to be, there's no x left. I don't know, maybe it was supposed to fail. So I know I could pull out a 2 and a y, and I would be left with a 4y to the 3rd plus 7. But, I mean, those 2 don't match, so I'm not happy. So I've been trying to think through maybe a different way to do it. Like I was saying, maybe if I put those 2 terms together, or those 2 terms together, and then those 2 terms together, but it's still not going to make me happy. I don't really think there's anything we could do on this one except what Jax did and plot the x. I really am stuck on 5. 2 I figured out. I'm not being blunt on that one, but I really am stuck on 5. So if you can figure out how to make 5 work by grouping, I will give you some extra. I'll give you 3 extra points on your next test, which will be one day next week.
So we have to like do that in like class, like read that.
No, I'm over it now. I'm moving on to the next one. But if you come back and show me you have figured out that one by grouping, I will give you 3 extra points on your test. Okay, number 2, Ellie originally said grouping. But what happens on number 2 if we try grouping the way it is? Okay, so in the second term I can pull out an x. What can I pull out of the first term? Nothing. A 1. And who wants to pull that out? So let's rearrange this one. Why don't we make it, I'm out of room down there. Let's put the x people together. Well, I mean, let's put the x and the b term together. So x squared minus bx. I'll put those two together. And then I'll put ab and ax together. And literally all I'm doing is pulling that one to the front, hoping maybe if I just rearrange the terms, grouping will work out. But my groups are working a little nicer this time because I actually can factor something out of both of them. What can we factor out of the first one? So if we factor out an x, we're left with an x minus b. In the second one, if we factor out an a, we're left with a. And they look really similar, don't they? They're almost alike, just not quite there. So instead of, and I'm going to mark through that line, even though that line is almost perfectly correct, but I'm going to mark through it just to get my mind right. So yes, factor out the x. Yes, you're left with x minus b. What if we factored out, what if we changed the order and we did, Miss Compton's writing all over the paper today. This is what she should probably write in pencil. What if we wrote x squared minus bx, and then we did the ax next, and then the ab last. Maybe by third period I'll have to figure it out. Because if I factor out the x, I'm left with x minus b. I agree with that on the first one. But on the second one, if we factor out a negative a, we'll still have x minus b, and then we're happy. So literally, I'm just rearranging the terms to try to see if I can force grouping to happen. And it just so happens that I can on this one. It ends up being x minus a, x minus b. Now, is that always going to magically happen? No. Should we probably be more patient than we are and persevere and try to make it happen? Probably. We probably should, but again, I'm offering 3 bonus points if you can figure it out, because my brain is over it today. So sad. Okay, if you've got your packet, we're going to page 7 of your notes. Okay, I am going to really disappoint Daniel today, because he's disappointed on number 5 because I've given up on it. He's really going to be disappointed on how lazy I'm going to be on determinants. Okay, so far we've done normal addition, subtraction, multiplication with matrices. We would like to do division. It's page 7. It says 7 at the bottom. We would like to do division, but division doesn't really work with matrices. We're going to have to do something called an inverse. It's the end of the week's problem. Your later self's problem. Anyway, so in order to do the problems we need to do coming up later in the week, we have to determine whether or not our matrices have determinants. Does it have a determinant? So if we end up getting 0, we have a problem. Houston, we have a problem. But as long as we don't get the number 0, life is going good. Okay, today we're going to do 2x2s and 3x3s, but you could also do the determinant of 4x4s, 5x5, 6x6, etc. What is it called when the rows and columns match? Gilberto, get a point. Square matrix. So we're only going to do determinants with square matrices. If you don't have a square matrix, don't type it in the calculator and ask it to calculate the determinant, because it won't work. It has to be a square matrix. You might want to write that down. Has to be a square matrix. Okay, on number 1, I don't see the normal brackets we've been seeing with matrices. Instead, I see something else. What do those remind you of? They look like absolute value signs. Ellie, get a point. However, what's the deal with absolute value signs? Your answer is always. That's not the case with determinants. It's okay to have a negative. So I'm going to put okay to have negs. So negatives. It's okay to have negative numbers. You can put the little negative sign. You can spell it out. It's okay if we end up with a negative determinant. Again, it's okay. So what we're going to do is we're going to do some fancy math. It's really not fancy. We're going to do some math. We're going to end up with one number at the end. And it's okay if that number is positive 42, negative 73. As long as that number is not 0, we're okay. If the number is 0, that's when what we're going to do next would come to a complete halt, because it just won't work. Okay, so I like letters, so if you want to write this down, you can. We're going to work enough where you don't need it, but if you like letters, I like letters in a process. So to find the determinant of a 2 by 2, we're seriously going to use the diagonals. We're going to do AD minus BC. So we're going to take the product of this diagonal and then subtract it from the product of this diagonal. And that's how you calculate the determinant. Which seems silly, but again, and while it does seem silly all by itself, we have to calculate the determinants in order to do our next step in matrix math. We've done all the matrix bases. Now we're to like the intermediate stage of matrices, and so you have to have the determinant in order to go from here. Okay, so for our first one, I'm going to do 6 times 7, which is 42. It's always this diagonal minus the other diagonal is 5 times negative 2, so negative 10. So it ends up being 42 plus 10, which is 52. Our next example, negative 6 times negative 1, we get positive 6, minus negative 4 times negative 3. I heard you, you're right. It's positive 12. So 6 minus 12, and our answer ends up being negative 6. So seriously, I'm just multiplying the 2 on the right diagonal and then subtracting from the left diagonal and getting a number, and that number is our determinant. So for our next one, I've got some decimals, so I'm going to need some help. I need 8.6 times 5, 43, go back to get a point, minus, I know 14 times 0.5 is 7. So 43 minus 7, which is 36. You can have a point. Table 3. Okay, so I got some more free points available. Go ahead, do 4 and 5. Tell me the numbers. I'll give you the points.
Negative 414 for 4.
Can you tell me how to do it?
You multiply 14 times negative 3.
And you got negative
42.
and then minus 72, and that's how you got it perfect. And you get a point for that, Angel. And then number 5.
144.
Tell me the two numbers.
Oh, 420 minus 276.
Perfect. And you get 144, you said?
Mm-hmm.
Okay, so are there any issues with these? Everyone's good. Okay, well then let's get to how to do it in the calculator, because you and I both know that we can do it in the calculator, because I'm going to show you strictly with a 3x3 how to do it in the calculator. But the sad bad news is that we can do all of this in a calculator. I think by the time I type in my matrix and tell it to do all the math, it's easier to do a 2x2 by hand. And let's face it, Cassidy's going to get more pity points out of me if I see like the circling and her with some numbers than her just having the wrong number at the end. But I want her to know all the things in life. So go on as always, second matrix. I'm going to edit matrix A. I'm going to type in number 4. So I need a 2x2. My entries are 14, 8, 9, negative 3. Is there anyone confused to here? Okay, so second quick gets you out of this screen. If we go to second matrix, we want to do some math today. And I already see determinant on the list. Does anyone else see determinant on the list under math with matrices? That top thing, DET, determinant. That looks like determinant, it is determinant. So I'm going to say, yep, that's the one I want. And then you do have to remember which matrix you typed it in as. So I typed it in as A, so second matrix, I want A. I ask it to take the determinant of A. Oh, look, negative 114. Now, seriously, I think Ryan can do this part by hand way faster. But if he wants to check himself or whatever, the calculator knows how to calculate determinants as well. Okay, so I am a math nerd, as you know, so I really like matrices, and I've taken a lot of classes in matrices, so I don't mind calculating a 3x3 by hand. However, life is what it is, and our goal is to get you as quickly to the answer as possible, and as long as you understand what comes next, like what we do with the determinant after this, it doesn't matter how you get the determinant. So for the 3x3s, I'm seriously just going to teach you how to put it in the calculator. I am going to post a link on Google Classroom, though, if you're interested in learning how to do it by hand, because it's really not a big deal. Not as easy as a 2x2, but not anything worth crying over, especially if you're like Tylen and you persevere through those systems of equations that had like 4 unknowns. You can do that. You can do the determinant of a 3x3. Okay, so on number 6, I'm going to type it in as matrix B. So second matrix, I'm going to edit B. I want it to be a 3x3. My entries are 3, negative 2, negative 2, 0, 4, 1, negative 1, negative 5, oop, not negative 5, negative 1, 5, negative 3. So I've typed this matrix into my calculator. So when I say second matrix, I want to do the determinant of that 3x3. It's literally going to tell me a number. So number 6, the answer is negative 57. Is there anyone who doesn't understand how I got number 6? Okay, well then here's the chance to get some more points. I need the answer to 7 and 8. You get a point. Number 7 is negative 63. 8 is indeed 54, and you get a point. Okay, is there anyone who doesn't understand how we're doing this? I must warn you that eventually we are going to press a different button. We're still going to press second matrix because all we're doing is matrices right now. But eventually there is another button additionally we will have to press. So you've got to make sure you're keeping DET as determinant. The easy things in life that are sometimes overlooked. Okay, are any questions about this? Then your new workbook assignment is literally stuff like this. It's page 41, 1 through 10, 19 through 22. If I call your name, I either have something for you or I'm needing something from you. If you need to come show me something, that would be great.